want to talk about. Thanks. So you have to write your own parser that will take an input and then give you the byte ranges and match those to the atoms that you're going to, or the non-terminals and terminals, the pieces of the parse tree that you want to use. That's definitely, that's left up to, the person that's using the tool. And then you have to I have some scripts right now that'll take that and generate the input you need to give the IDA tool to draw the trees, but it's really ugly, and hopefully it'll get better. There are a lot of places to go with this, and I think one thing would be to use the Dion taint analysis. They've spent a lot more time doing, because x86 is ugly. I mean, anyone that's ever used it for a long period of time, there's a lot of corner cases, a lot of things you have to consider, stuff you have to do, especially when you're doing this taint stuff that I'd probably get wrong. So I'd like to steal that from someone. And then drawing the parse tree I'm really doing it wrong. I really do want to steal that antler stuff, and I think it'll look a lot better in there. Any other questions? Yeah.
When you're running the traces, I would imagine when Ken is doing the instrumentation, it's not slow when it's actually running through.
That's right. Yeah. I don't have a way to negatively do it. So the way it works now, like I was saying, there's like that start the origin of the trace, right? That actually works on a stack level, because exceptions and things, a lot of parsers use an exception to sort of jump way back out of the parse. And if you don't do that, then you're never going to turn your trace off. So that's what that does, I don't have a way to then prune the tree deeper in there. Like, if you say, oh, you get to this part of the binary, I don't want to look at it. But I think that's not too difficult to do with pin, because I have the tools to do it the other way. But that's interesting. That's a pretty good idea. I haven't gotten that far yet. Any other questions, please? No? All right. Well, yes. Yeah, you said Flare, right? Yeah, that's a really cool tool. That's a little slightly different. So what they do there, I think, correct me if I'm wrong, I know people are here, know about this tool. Flare is an in-memory fuzzer, I believe. And there are two things it does, I think. One is that you're allowed to force certain paths along the binary to try and exercise pieces that are harder to access. What else does it do? I'm trying to remember. I'm not sure. So it's slightly different than this. With Flare, what you're trying to do is exercise other parts of the binary that you're not sure how to get to without actually solving the Dataflow equation to get it there. It's a cool tool. They did a really good job, but that's slightly different. Any other questions? Questions? All right. Well, I think that's everything I have. You can come up and talk to me if you didn't want to raise your hand, or you can send me an email. I'll go way back up here. And please send me an email if you're interested. I'm going to be releasing all the code on bitbucket.org by the end of the weekend. And play with it. Let me know how it goes. Like I said, and it's obvious, it's really young, but I think it's going to be something useful since no one wants to release their code for this. I'm willing to give it a go. Thanks for your time. I hope it wasn't too dry and boring. I don't know how to make this any more interesting. Thanks.